handle these null values. So next we have something called Boolean. Booleans are basically true or false. We can think of them as yes or no, or switch on, switch off. I'll explain them further later on. Then next, we have strings. Strings are just text, like you see here. So hello world is a text, hello is a text. I'll also explain them later on. Numbers are straightforward, just numbers. Can be decimal, can be negatives, can be just whole numbers like 5 like that. And finally, we have objects. So objects basically is a way of storing key value data pairs. So I will explain this on later on as well. So in JavaScript, you can do math operations on numbers. It's very, very similar to like what you did in math. So if you want to do addition, just do plus, minus, you can do minus. So in this math operations, you can mix around the numbers. You can do whole numbers, you can do decimal numbers. JavaScript wouldn't really care. If you are in other languages like maybe Swift would care. They are very, very strict about these kind of things. Then there's multiply. You notice that it's different. It's not X, it's the asterisk, like how you would see in some calculators. You have divide as well, which is different. And you have something called modulo. Modulo basically gives you the remainder of your division. So if you have 10 modulo 3. So the nearest multiple of 3 from 10 is 9. So that gives you a remainder of 1. So 10 modulo 3 will give you 1. Okay. So there are some shortcuts in JavaScript that you can perform as well. So you can easily like increment, basically means add 1 to variable with the plus operator, like you see here. So first I have a variable called num, which equals to 1. So if I do num plus plus, now num will equals to 2. So you can see it's the same as this lah, but it's a very, very short form of doing it, which saves you time writing, especially if you're typing really fast and you just don't want to be so witchy about certain things. So similarly, you can decrement or decrease a variable by 1 with this minus minus operator. So if I do num minus minus, now num will be back to 1 over here. And if you notice, there's a common pattern if you have read on over here and here lah. So JavaScript has exploited on this common pattern, or rather all programming languages does that lah, and they do a short form for it. So one of these examples is plus equals. So what this does is it simplifies this expression over here. Basically it's saying you take the data inside this variable num, you add 2 to it, and you store it back inside num, which is what it's saying over here. So this is a simple way to increment your number or perform whatever math operations on that variable. So this applies for other math operators as well. So things like minus are multiply, divide, modulo. Okay, next, strings. So strings are simply text containing alphanumeric letters, spaces, and symbols. So here we have a string. We call it a string literal. When you see like a string directly represented like that, we call it a string literal. It's a string because it's a series of 0 or more characters enclosed in either a single or double quote. So you can write this as hello world like that. this is a valid string as well. So you can either use single or double. But you must always define a string with a start and an end. So a tricky part comes when you want to add a literal quote inside. So something like he said hello. So in English, you will write your quote here like that, right? But if you were to add this quote, this end quote without this slash thingy lah, you will end your string here. And then you have this strange thing here. Or rather JavaScript sees this as strange lah. So how we can avoid that is basically to add this backslash. This is called escaping a quote, which basically signals to JavaScript that the following quote is not the end of the string, and it should appear inside the string. So this string here will be fully called, he said, colon, open inverted comma, hello, full stop, close colon. So that is a full string. So alternatively, you can also do single quotes. So single quotes allows you to use the double quote inside without having to escape them, because JavaScript will look for a closing single quote to signal the end of the string when you start it with the single quote. So since it sees a double, it doesn't recognize it as an end. So it will just continue on until it finds this. So it will get this whole string over here. So quotes are not the only characters that you can escape inside a string. So there are mainly two reasons to use one reason to use escaping characters. So they allow you to use characters that you cannot otherwise be able to type it out, such as a line break. So what is a line break? You can also call it a new line. So if you see over here, I have a line break over here, \n. That basically gives you this line break over here. So if you do a console log of multi-line string, you will print out hello world in two separate lines and not hello world in one single line. The recording will not be shared after the workshop, so try to pay attention. So we won't be sharing the recording for now. Okay, so in JavaScript, you can also combine strings together. So we use the plus operator to combine strings. And combining strings is basically called string concatenation. It's a very long word. So you can build new strings out of other strings by concatenating strings together. So if you see here, I have a string called hello, and it's assigned to the variable greeting. And then I'm getting greeting, then adding or concatenating the string world behind it. So you see, I'll get a hello world string in no space, the variable no space. So you can notice that I have no spacing here. So you need to watch out for spaces when you do concatenation. So when you combine strings together, JavaScript will not automatically add spaces between the strings. So you will need to add them yourself. So you can see here, I'm adding this space over here to greeting. So similarly, I can do some compound assignment over here, the plus equals to, and then I'll get the hello world with a space over here. You can also, find how many characters there are inside a string by doing something called dot length. So if you do a console log of length of string, you'll get 11 out. So the length of a character also includes spaces. So spaces is considered as one character as well. So let's say we want to get some characters inside a string. How do we do that? So we can do it via something called bracket notation. So it's a way to get a character at a specific position, or in programming or computer science, we call it index. So see, we have a name variable, and we assign a string called Charles. I've broken it down in this table over here. So we have a string Charles here, and then we have the index here. So if you notice in JavaScript and in most modern programming languages, we don't start our index with 1, like natural numbers. We start it with 0. So this is called zero-based indexing. So our first character here is at index 0. And if you tell JavaScript that we want the character at index 0, you'll get C. Or if you want the character at index 3, you'll get R back. So how we do that is via this bracket notation over here. So square bracket notation over here. So inside, we put the index that we want. And then we append this bracket notation behind the variable containing the string. Oops, sorry. These three are supposed to be named. So when we do that, our first char will be equals to C because that's the first character. So how do we get the last character? You remember we learned about dot length, which is to get the number of characters in the string. So in order to get the last character, we can do dot length, the string dot length, then -1. So this child string has 7 characters, right? 7 characters. Char. And since we start at 0, our last char is at index 6, or rather 7 - 1. So why not do string 6? So that's because normally for example, one way to handle strings is when you are handling user input. So for example, you want your users to type in some password, and your password must be at least 3 characters long, or rather it must end with a certain character. Okay, not password, username. It must end with an exclamation mark. So in order to get that, you need to access the last character of the string. But your users can input any number of characters. You can input 7 characters, you can input 8, 9. So if you do a string 6 here, you will probably get something in the middle and not the last, because you can never predict what your user put. So string.length -1 is the only way to get the last character of the string out without having to guess or without having to hard code the index inside. So these will cater for all cases, for all length of strings. And what will happen if you try to access something that's outside here? So things like string.length. So it will give you an error. Okay, next, we learn about arrays. So in variables, you can store a single data. So now, arrays help us to store multiple data into one variable. So how we represent arrays is using square brackets. So these are square brackets. So you can think of arrays as shelves. So with each shelf, storing one data. And we can store this shelf inside a variable. So we have a, you look here, we have a variable called array of names. And then inside, we'll have a shelf. Then this shelf will store Alice. Done by handwriting. Yeah. So this variable will store a shelf, or we call it an array, and this array will store multiple data. So the first data inside it is called Alice, and the second data has a string of Bob. So in these arrays, we can store any data type. We can store strings, we can store numbers, we can store Booleans, we can store objects. But of course, the complexity increases as you store more complex stuff. So how we represent array, apart from the square brackets, in between each item, you put a comma there. So this tells JavaScript that I finished with this. This is my first item. This is my first item. And I end it with a comma, and this is my second item. And if this is our last item, you don't put a comma there, and you just close it off with the square brackets. So similar to strings, we can also access the data inside arrays using indexes or the square bracket notation. So the only difference is that instead of specifying a character inside a string, as we would do with a string, the square bracket notation specifies an entry in the array. So like strings, arrays also use zero-based indexing. So they start with 0. So if you see here, we have a variable names with an array of strings. So we have 3 elements inside this array. We have Alice, Bob, Charles. So the first element inside the array, Alice, will have an index of 0. And the last one will have 2. So similarly, in order to get the first entry, you can just do 0, square bracket 0. If you want to get the last entry, you can do dot length -1. So you can also modify your arrays using the bracket notation, which is you see over here. So instead of assigning them into a variable, you're directly telling JavaScript, look at the first element inside this array and put ND inside it. So now names will have ND inside as its first variable, as its first element instead of Alice. So there are some other methods that you can use to add data or remove data inside an array. So an easy way to append data to the end of an array is via the push function. So we'll learn more about functions later on. We'll learn about these operators first. So push will take one or more item, and then it will push it to the end of the array. So we have a variable, similarly, names with an array of strings. So we do a dot push with some parentheses here, and then we put the item that we want to put at the end of the array inside the brackets, inside the parentheses. So after doing that, you will see that name will have Daniel as its last element. So another way to change the data in an array is with the pop function. So pop is used to pop off a value at the end of an array. So it moves it from the back of the array. So this is a bit special because we can, after we pop it off, we can store it back into another variable, like what we did here. So remember, when we are assigning a variable, we can put an expression here. So using pop is considered expression, function expression, and it will evaluate this here. So pop will give you back the last item of the array and also remove it from the array. So once it gives you back, you can store it back inside this variable pop last name. So now pop last name will have the value of Daniel, the string Daniel, and the names won't have Daniel here. So push always adds element to the end of an array. But what if you want to add it to the front? So that's where unshift comes in. So it works just like push, except it adds to the front instead of the back. So unshift, Daniel similarly, but now you see Daniel is at the front instead of at the back. So not only can you unshift elements into the front of an array, you can also shift elements off the front of an array. So you're removing elements from the front of an array. So it works exactly like pop, but instead of removing it from the back, remove it from the front. So if I do a dot shift, on names, I will get back Daniel because I'm assigned. So I'll shift first name with the data of Daniel. And then you can also see that name no longer contains Daniel at the front of the array. Okay, next, functions. So remember I talked about functions just now. So what are they? So they're basically blocks of code which we can call over and over again. So that's when we want to divide our code up into reusable parts. And these reusable parts, we call them functions. So how do we create and call a function? So when we try to run a block of code that is inside a function, we term this operation calling. So first creating, we put this function keyword at the front, and then we put the name of the function. Then we have some parentheses here. And then we do curly braces. And this will be the body of a function. So whenever you try to run this function, or we call a function, it will run whatever is inside the body of the function. So a function can also accept inputs and return outputs, which I will tell you more later on. So in this example, we have a function called function name, and in its body, we have console log hello world. It's basically printing out hello world. And here we do it 3 times. So when you first create a function, so in this part, JavaScript won't run the function. JavaScript will just know that, hey, you are creating this function called function name, and in this function, you are doing console log hello world. That's all that Java does, create a function. Then next, in this line, you are calling a function. And how we call is basically we put the function name there, and then you do a parentheses. So now that this is called, JavaScript will loop back, and then it knows to do console log, so it will print out hello world. And then it will go back to the end, and then it will go to the next line. In the next line, you're calling function name again. So it will go back again and do a console log. So hello world is printed out a second time, and then it will go back. Sorry, the messiness. And then we go down the lines of code. We go to this one, function name again. So we are going up again, doing console log, and we're going back down. So in total, hello world is printed 3 times. So you can see where the reusability comes in, because I only have to write the function name with this brackets in order to execute whatever is inside this body, whatever is inside the body of the function. So you can imagine that the function can contain a lot of code. And if you want to do this operation many times, you don't have to keep writing it out. Copy paste. So one thing that is shunned upon in programming is copy pasting your code. So you don't want to repeat yourself. And that's where function comes in. You can just call this function and whatever that's inside the body will be executed. So next we'll introduce something called parameters. So parameters are basically variables that act as the input to a function when it is called. So remember I said that a function can have some input. So when a function is defined, you typically define it along with 0 or more parameters. So see here, I have a function called function with params, and then I have 2 parameters here. I have a parameter called first param. I have another parameter called second param. And they basically represent the inputs of this function. So if you see, I call it here with 2 values, hello and world. Because hello is the first value that we give to the function as an input. So when you go back up here, first param will equal to hello. And because world is the second one, because world is the second input, second param will equal to world. So when you console log first param and second param, you are console logging hello world out. So you can imagine where the reusability comes in again. This function can take in any kind of input. It can take in any kind of strings, any values of strings. And I basically just represent them as first param and second param. So if you look at this second function call, I'm giving it good and bye. So now first param equals to good, second param equals to bye. And my console log that out, goodbye would be printed. Okay, so if you see, Jonathan asked, why won't the output be hello world without a space? So here I put a space here. If you notice, I'm doing a comma over here. Sorry, not this. I'm doing a comma over here. I'm not doing a plus. Comma will basically print the values with a space in between them. So I have 2 values over here, separated by a comma. So it will print this. It will see a comma, it prints a space, and then it will print the second value. So this is special only in console log. You can only do this in console log. You cannot do it like I cannot do this. This is wrong. It will give you an error. So that only happens, you can only do comma inside of console log. So next, we'll learn about something called scope. So in JavaScript, scope refers to the visibility of variables. So basically whether you can use a variable or not, or whether you can access a variable. So variables which are defined outside a function block. So we call a curly braces and anything that's inside it a block. So variables which are defined outside a function block has global scope. So I have a variable here called global var. and this will have a global scope. So they can be seen everywhere in your JavaScript code. So even inside this block, I can see a global var. That's why I can print global var out. So when I execute this function, print global var, I'll go up here, I'll do a console log of global var. And then JavaScript can go up here and see what is the value of global var. Equals to 1, and so 1 is printed out. Next, variables which are declared within a function block, as well as the function parameters, they have local scope. This means that they are only visible within that function. So I have a local var here. This local var is a local scope. So if I do a console log of local var inside this function block, that works. So if you see, I call this function print local var. I go up here. I initialize a variable local var to 1, and then I log it up. I print it out, and it's successful. 1 is printed. Next, I try to do a console log of local var. So you see, this code over here is already out of the scope already, out of the local scope of this function. So over this statement here has a global scope. So if I try to do that, I cannot access local var because they are only visible inside the function. And when we try to do that, we get a local var is not defined because we don't have a local var variable in the global scope. So let's try to mix them together. So it's possible to have both local and global variables with the same name. So when you do this, the local variable will take precedence over the global variable. So local will come first. So you see, I have a global variable called var with same name. I give it a string value of global. Inside this function, print var, I have a local variable with the exact same name, var with same name. And I give you a value of local. And then in this function, I log the var with same name out. So when I run this function, I go up here, I initialize a local variable inside this function called var with same name to the value of local, and I log it out. And since it's equals to local, inside this local scope, local is printed. Now after I execute this, I go out, and then I come here. I console log var with same name. Now this statement is in the global scope already. And in the global scope, I have this variable var with same name with the value of global. And that's why global is printed. So you can see I have two variables with the same name, but they print differently depending on where the console log is. And the reason is got to do with scope. So next, we have return value. So our functions can have some inputs, right? So we can also give an output from the function after executing a function. So you can use a return statement to send a value back out of a function. So here I have a function called +3, and I have an input. I have one input, and this input parameter is called num. And I return num +3, which matches what our function name does. We want to +3 to an input. So here we are using the function. So when we run this code, remember the right hand side will execute first. So we'll execute this function. We'll go back up here. and num will equals to 5 because you are giving it 5. So 5 plus 3 equals to 8. So and that 8 value will be returned from the function. Because it's returned, it is assigned back to the variable answer. So this way we can run the function and then get back its output and then store it inside a variable. So you can see why this is helpful because if you just do plus 3, without assigning it to a variable, it's basically useless. Like you're just doing 8 plus 3 and you're returning out of the function, but you don't do anything with the result. It's like asking someone to print something out, but you just leave the stack of paper that's printed out from the printer at the printer there, and you're not using it at all. But you want that person to hand that stack of paper back to you, and you have use for that paper. So similarly, when you return the value, you need to assign it back to a variable so you can use it later on. So as mentioned, so functions are useful when some code is consistently used and you want to encapsulate a piece of logic that will be constantly reused. So remember we talked about push, pop, shift, unshift. So these are all functions. They are functions that work on an array, but the way we represent them is different. So if we have this, notice the way we represent them is a bit different in that we put the variable name containing the array at the front. Then we do a dot, and then we put the function name, as opposed to push to. Because if you do just push to, it doesn't tell you like this push applies to what array. That's why we have this notation over here. To specify what array is you're pushing this value of 2 into. Okay, so one example of a useful piece of logic would be things like formula. So when you want to calculate an area of a circle, you basically need just the radius of the circle, and then you apply the pi r square formula, and then you get back the area. So similarly, you can do this in code by encapsulating this piece of logic, this formula inside a function called area of circle. And this function will need an input radius, and it will return out the area of the circle. So in JavaScript, we often don't need to name our functions, especially when we're passing a function as an input to another function. So instead, we try to create inline functions. So we don't need to name these functions because we don't want to use them elsewhere. So what inline functions are is basically a short form for creating functions. So this is an inline function. I just start with the parentheses. I do this arrow, and then I do my curly braces, and the body is inside. So this is what we call an inline function or an arrow function. So what you see here, you have this parentheses, and similarly, you can put any inputs to the function inside. So this function has one input radius, and then in the body, you are returning 3.1, the area of the circle. So there are some short forms with regards to arrow function. So when there is no function body and only a return value, so like for example there's no other body except this return statement. The arrow function syntax allows you to omit the return keyword as well as the curly braces surrounding the body. So you can simplify these smaller functions into a one-liner statement. And similarly, if your function has only one parameter, like here, there's only one parameter radius, you can omit the parentheses around them. So here, notice I don't have parentheses, I don't have curly braces, and I don't have a return keyword. And lastly, we have something called rest parameters. So in order to help us create more flexible functions, ES6 introduced the rest parameter. So it's represented by this ... here for function parameters. So with the rest parameter, you can create functions that take a variable number of inputs. So in programming, we call inputs arguments as well. So if you hear me saying them differently, if you hear me saying arguments, they basically mean inputs. So these arguments will be stored in an array, which can be accessed later on from inside the function. So here I have a function called how many, and I have a rest parameter here. I'm calling it args. So how you would use it is here. You notice that here I have 3 elements, whereas here I have 4 elements. Or 4 arguments, sorry. So you can see that the number of arguments I give it is variable. So previously, this only takes one argument. So if you give it 2 arguments when a function only requires 1, JavaScript will give you an error. Whereas in a rest parameter, you can give it any number. And these values will be stored inside an array. So in this case, I'll have this. The args will be equals to this array containing the inputs. And then we have learned that in order to calculate the number of elements inside an array, we can do .length. So I'm doing this here. I'm returning a combination of strings. So I combine you have pass plus the length of the array and combine with arguments. So when I run this function, I'll get back you have passed 3 arguments and I'm printing it out via console log. So you will see you have passed 3 arguments out. And similarly for this, because I have 4 arguments here, my args.length will be 4, and I will print out you have passed 4 arguments out. Okay, so now it's time for a 10 minutes break. So if you have any questions, you can ask in the Team chat or in the Padlet. I understand it's a bit intense, especially since it's like just a 1.5 hour to a 2-hour workshop. They are cramming maybe 3 weeks of a module inside. So it will be slightly fast, especially for those who have programming experience. So if you have any questions, you can just ask in the chat. If you find me talking too fast, too slow, you can also feedback. Then I'll try to speed up or slow down in the next session. Okay, so someone asked, how do you call arrow functions to use after you create it? So remember I say that arrow functions are nameless, but okay, my examples here are a bit careless. I'm actually sort of naming it because your variables can also contain functions. This is where things get a bit tricky. You can treat functions as data as well. And because of that, your variables can store data. And here I have a constant variable called calc area of circle. And in some sense, I have a function called calc area of circle. So this is a named function. So I make careless about this. I will explain when the unnamed comes in later on. So how do I call an arrow function? It's basically the same thing. If I have a name for it, I'll just do calc area of circle. And then same thing. I'll just do the parentheses and give my input inside, give my argument inside. But if it's unnamed, so when the unnamed comes in, right, it's when you're interacting with other kind of code. So imagine you're writing a button, right? So like when a user clicks on button, something will happen. Some code will be executed. So typically how other frameworks will do is they will ask you for something called onClick. They will ask you to give some function here. So instead of writing it out, an onClick handler, a handler basically means like what will happen when you onClick, or what will happen when some event happens. You handle an event. That's why it's called a handler. Instead of writing this thing out, right, because you're not going to reuse it anymore. And remember, in functions, you want to reuse it. You don't have to write this block out. You can just do onClick equals to this, and then the body. This way, you can make use of arrow functions without having to create named functions over here. So I have a name function here, I have an unnamed function here. And how it's being used, you don't really have to know. It works behind the scenes. That's why it's when this framework's asking you to provide an onClick handler. That's why I put an onClick equals to something. So they are specifying, hey, give me some handler for when a user click this button, and you provide an arrow function. Then the framework, right, will go and execute the function when the user clicks on it. You're not the one doing the calling yourself. The framework will handle that for you. So that's the usefulness of arrow functions. Did I answer your question? You're welcome. How do we progress on this workshop? Any suggestions? So we have a third workshop in this series for front-end development. So it's about interacting with the DOM. So it's like combining what you have learned, HTML, CSS, and JavaScript to create a web application. So you can attend this workshop and know more about combining these three technologies together. If you cannot make it for the third workshop, you can also read up more about these three core technologies, so HTML, CSS, JavaScript, and see how to create a website yourself. You can also learn about certain web application frameworks. So some of these frameworks, examples, they are React, Angular, Vue. There's also Svelte. That's how I spell it. Yeah, but Svelte is more complex and you don't really create. People do create web applications with it, but it's not really very popular now. But it will become popular. So you can explore with all this. So React is one of the biggest frameworks now. So I realize I need to clarify what frameworks are. Frameworks are basically some way of creating a website that other people have created for you. So instead of really go and telling the browser one by one, go and render this text out. Then when the user go and render this button out, then when a user clicks this button, go and do this. Instead of you yourself doing that, a framework helps you to simplify that by saying like, hey, I will take care of all these operations. You just tell me what to execute when the user clicks this button. You just tell me what to show to the users in this page. I will go and handle all the rendering out in the browser for you. So that's what a framework does. So React will do that, Angular will do that, Vue will do that. So these are just some suggestions to progress on from this workshop. I will start at about 8:70. Okay. Now I'll move on to the next section. Now I'll talk about Booleans. So if you remember, Booleans are basically just true, false value. Yeah, something like on, off, yes, no. So where true is on and false is off. So these two states are mutually exclusive. So there won't be a time where there's something that's true and false at the same time. So here it's a very simple variable initialization, and I'm initializing it to true. So you notice I have no quotation mark here, which makes it not a string. This true word here is an actual data value that is recognized by JavaScript. So how do we use Boolean values? So we're using something called control flow. So control flow basically means what part of the code you want to execute, and according to some kind of condition. So if this condition is true, then execute this code. If not, then execute another code. So we'll learn about this this section. So we can do that using an if statement. So if statements are used to make decisions in code. So the keyword if tells JavaScript to execute the code in the curly braces, so over here, under certain conditions defined in the parentheses here. So these conditions are known as conditional expressions, which I will cover on later. And these expressions will only evaluate to true or false. You cannot evaluate, okay, wait. In JavaScript, you can evaluate to some value, but it's not very intuitive. In JavaScript, sometimes undefined means false, null means false. If you have some value like 1 or a string present, it will evaluate to true. But I won't go too much into that. JavaScript tends to mix them up, which is a bit confusing. So now I will just say that this one will evaluate to the Boolean value true or false. So when the condition evaluates to a true, the program inside here, the lines of code inside here will be executed. So when the Boolean condition inside here is false, here will not be executed. So how do we execute something else if it's true? So we add an else statement here. So if this condition is false, here will be executed. So it's quite simple on-off. You get the on-off analogy over here. If it's on, execute here. If it's off, execute here. So you can chain this kind of if-else statement as well. So if you have multiple conditions that need to be addressed, you can chain if statements together with else if statements. So over here, I have a first condition here. If this condition 1 is false, I will evaluate this second condition. Then if it's true, I'll execute here. If not, I will not do anything. Then you can see where the chaining comes in. I can chain multiple conditions here. Condition 2, condition 3, many more conditions here until an else block. So this statement end or body will only be executed if all your conditions in this if else block evaluates to false. So just now I talked about conditional expressions. So what exactly are they? So they are just some mathematical way of, can be mathematical, can be with regards to strings, can be some form of function that returns a true or false value. So we can do that by using comparison operators, especially when we are dealing with like numbers lah. So first thing is called equality operator, which is this double equal sign. So the equality operator, you will compare two values and return true if they are the same and false if they are not. So you notice it's different from assignment. Assignment is equals. This is double equals. So over here, I have one equal to one. So this is obviously true lah. So this expression over here will return true. I have one, I will try to test if 1 is equals to 2. And since it's not, it will return false. So the equality operator can also compare the value between numbers and strings and return whether they are equal or not. So in order for JavaScript to do that, to compare two different data types, it must convert one type to the other. So this is something known as type coercion, which I've mentioned just now, where you can mix numbers and strings and Boolean together. You can see why it comes to be a little confusing, because you're saying a number equals, you're testing if a number is equal to a string. And when the string is converted to a number, so this string here, 1, will convert it to number 1. And since the number 1 here is equal, number 1 here is equal to number 1, it will return true. So if we don't want to do this, we can do something called strict equality, which has 3 equal signs. So unlike the equality operator, which attempts to convert both values being compared to a common type, this strict equality operator doesn't do this type coercion. So if the values being compared have different types, they are considered unequal and it will return false. So you see that over here. This will return false. The next two are just inequality. They're basically the same thing. The first two are testing whether they are equal. Inequality are testing whether they are not equal. So it's the inverse lah. So one, you're testing is over here, the value 1 is not equal to the value 1. But since they're equal, you return a false. Because 1 is not equal to 1. And similarly, you can see the strictness comes in as well. So I have this, I'm still returning false. I have this is a number, this is a string, and they are not equal, so I return true. Next, we have some things very, very similar to math as well. So comparison operators that deals with numbers. So we have the greater than. So if 5 is greater, testing if 5 is greater than 3 is true, so we return true. So this greater than and or greater than or equal or any other operator here lah, in this slide, they will do type coercion. So if you see here, you will return true. Greater than or equal to, we add this equal to at the back. So over here, this example, we're testing if 3 is greater than or equal to 3. And since 3 is equal to 3, we return true. And the same thing for less than and less than equal to. Then we have something called a not here. Some people call it a not operator. You can think of it as like inverting a Boolean value lah. So if you invert a true, you'll get back false. If you invert a false, you get back true. So these are helpful when you're dealing with, when you want to find out the other side of the coin. So let's say if you're trying to find out if a string is empty, if an array is empty. So you can do this. This is equals to, this will be true when the array is empty. So what if you want to find out it's not empty? Then you just do this. So when the array has some items inside, so let's say this one equals to 1. Is 1 equals to 0? It's not, right? So here we'll evaluate to false. And since I'm doing a not over here, we'll evaluate to true. So this is one example of putting them together. So I have a simple function here that checks whether a number is 0. I take in a number input and I return this conditional expression over here. I check if number is equals to 0. Then I have this function over here. It's called print greeting, and I take in a code. So if this code is equals to 0, our console log out hi. Else, if it's more than or equals to 1, I will log out hello. Else, I will log out goodbye. So here, right, and here, they are the same. because if you look at the number line, 0, I'm printing out hi. More than or equals to 1, I'm printing out hello. So the rest of the cases would lie -1 onwards. And goodbye to goodbye, which is what we want over here. Okay, so this is one example of using conditional expressions and if-else statements together. So next, looping. So what happens if you want to run code multiple times? So there's two ways to do it. So the first type of loop is called a while loop, because it runs while a specified condition is true and stops when that condition is no longer true. So look at this example here. I have an array, an empty array. I have this variable I equals to 0 here. So while I is less than 3, I execute inside. So what do I do inside this while loop? I will push I into the array, and then I will increment I. So at the start, right, our array is empty and I is equal to 0. After the first loop, I push I into the array. So I will get 0 inside the array, and I increment I, and so 0 plus plus will be equals to 1. So I equals to 1. Then you check the condition, check I, whether is it less than 3. So now I is equals to 1, is less than 3. The condition is true. So you run the loop again. So at the second loop, now I equals to 1. So I push 1 into the array and I increment I 2. Then I check, is it less than 3? It's still less than 3. I run it the third time. So in the third run, I push 2 inside and increment 3. Now I go back up. Is I less than 3? And since I is 3, so 3 is not less than 3 since they are equal. So this condition here now is false. So I finish the loop and I go up. So at the end, array here will have 0, 1, 2, and I will be equals to 3. So now you can see that this chunk of code here is ran multiple times. So you don't have to like keep doing array dot push 0, then array push 1, array push 2. You can just do this and you can push sequential items together. Since our end condition here is just 3, right? It seems very trivial lah. But imagine if you want to push a sequential number of up to 10,000, you cannot. This one you have to repeat for 10,000 times, which is very legit lah. So doing this will help. So the second type of code loop, which is the most common type, is called a for loop, because it runs for a specific number. Loops are declared over here. So the first expression is called the initialization statement. So the initialization statement executes only one time before the loop starts. So it's used to define and set up your loop variable. I'll explain what is a loop variable later on. So the condition expression, the condition statement, the second one, is evaluated at the beginning of every loop and will continue as long as it evaluates to true. So if your condition is true, the loop will run again, similar to your while loop. So when the condition is false at the start of the iteration, the loop will stop executing. So the final expression is executed at the end of each loop. So it's typically used to either increment or decrement your loop variable. So we can look at an example here. Here we are initializing a loop variable called I, and this is our condition. So we'll keep running this code. We'll keep looping this code over here if I is less than 3. And at the end of each loop, at the end of each iteration, you increment I by 1. So at the start, I equals to what? I equals to 0 because we initialize it over here. Remember, this initialization is executed only one time before the loop starts. I equals to 0. You check. I is less than 3 is true. So you run the loop. So you push I into this empty array. And then you reach the end of the body. You increment I. So now I equals to 1 and it's less than 3. It's good. So you go inside the body and you push I inside. So we can continue on until I equals to 3. I equals to 3, this condition will evaluate to false, and then we'll go out of this loop. We'll stop the loop. And by then, our array will have 0, 1, 2. So if you find this familiar, right, it's because they're exactly the same as what we covered in the while loop just now. They're just different way of doing things. So your for loop, you can write it exactly the same way as your while loop. But you can see that this is cleaner because everything that is regards to the loop, everything that sets up a loop, that maintains your loop, that checks whether the loop is still, the loop condition is still true or not, is found in this single line. Whereas here, right, you set up here, then you do check here, then you increment here, it's all over the place. So this is cleaner. But there are some use cases for while loop, which I won't really cover here because it's out of the scope. So some examples of looping. So iterating through even numbers. So let's look at the for loop here. I initialize my loop variable to 0. I'll end the loop only when it's less than 10. And each time you run the loop, I increment it by 2. And then I push this loop variable inside this array. So at the end, you see that I've iterated through even numbers because I'm incrementing it by 2. So I start with 0. It's less than 10. Loop is okay to go on. I push 0 inside. Increment by 2, and I equals to 2. It's less than 0, I push it. And so on and so forth until I reach 8. 8. At the iteration where I equals to 8, at the end of it, I'll increment to 10. It's not less than 10, so I will not execute the loop. So similarly over here, I can do the reverse. I can initialize it to some non-zero value, and then I do a decrement. And then I check whether it's more than 0 or not, which I will end up with this. So these are just some examples of looping. So the complex part comes in when you have really layers upon layers of arrays and groups. So we have something called multi-dimensional array. So they're basically arrays in arrays. So here we have a 2D array. You can see I have an outer array here. And then each of the element in this array is an array itself. You can think of this as a matrix. In fact, this is a common use of 2D arrays. They are used as matrix. So the row corresponds to the element in the outer array. The column corresponds to the element in the inner array. So if you look at the first element in the outer array, basically say look at the first row. Look at the element, the first element in the inner array, looking at the first column, you get 1, which is what you get over here. Then next, we can look at nested loops. So there are basically loops inside loops. So you can see a for loop here and another for loop here. So I set up different loop variables, I and j. So you cannot set them both to I because they will clash. When I is equal to 0 here, if you make this equals to I, then JavaScript will say that I already have a variable called I there. And it will not allow you to do that. So in the outer array, each time I go one iteration, I first set up my empty array here. Each time I go to the, sorry. Yeah, each iteration in the outer array, I'm letting this array be the first element in the outer array. So now array equals to this first element. And then in the nested loop, the inner loop, I'll loop through the elements in each of this inner array. And then I'll log it out. I'll log the element out. So at the end, this will print 1, 2, 3, 4, 5, 6. But each on the new line, but I cannot put it here. It's not yet very huge. You can try this out in the REPL it, the code that I've provided, and try to tinker with it. Like change this, or even change the increment. You can increment by 2, by 3, and see what will happen. Lastly, we cover objects. So objects represent real-world objects. So we store, they are similar to arrays, except that instead of using indexes to access and modify their data, you access the data in objects through what we call properties. So they are useful for storing data in a structured way. So these are called properties. And how we represent objects is using curly braces. So in an object, we have a property to a value pair. I've written it over here. So for example, name is a property. This is its value. And then I will do a comma and another property. You see a comma and another property over here. So in this cat object, I have 5 different properties. I have name, legs, tails, enemies, and favorite food. And each of these properties, I store the value of them. So this cat has a name of Whiskers, has 4 legs, has 1 tail. Water and dogs are its enemies, and has a fish as its favorite food. So you notice that this has quotes, whereas this doesn't have. So what is the difference over here? So here you see there's a spacing. If there is spacing in the property, you need to use quotes. If there isn't, you don't need to use. So how do we assess the values in a certain property? So there are 2 ways to assess that. So it's either through dot notation or bracket notation, similar to an array. So dot notation is what you use when you know the name of the property you're trying to access ahead of time. So if you see over here, I'm getting the legs property out from this cat object, and I'm storing it into this variable called cat legs. So at the end, cat legs will be equal to 4 because the cat has the value of 4 in its legs property. So this is what we call a dot notation, dot property. So dot property. Then there's also the bracket notation. So if the property of the object you are trying to access has a space in its name, you will need to use bracket notation. So you cannot do favorite. So this is an error lah. JavaScript won't recognize it. So you can get the favorite food property out from the cat object. So at the end, the cat favorite food variable, if you have assigned back, if you have returned the value back to this variable, will contain the value of fish, because it has a fish as its favorite food. Next, after you have created a JavaScript object, you can update its value, its properties at any time, just like you will update any other variable. So you can either use your dot or bracket notation to update. So here, I'm putting it at the left-hand side now, and I'm assigning it with a value of milk. So when I console.log out, when I get this property out, I will print milk because I assign milk into the favorite food property of cat. Next, if you want to add new properties to existing JavaScript objects, you can do the same way you would modify them. So now I'm going to add a new property called nickname. So I just do it on the left-hand side, cat.nickname, and I give it its value. So now cat will have a property called nickname with a value of 4 to it. What if I want to delete properties? So you can do it through this delete keyword. So delete some object, its property. And then at the end, you'll see that I have no enemies here. Enemies is deleted from the properties of the cat object. So the tricky part comes in again with nested objects. So sometimes you want to store data in a flexible data structure. So a JavaScript object is one way to handle this flexible data. So they allow for like different combinations of strings, numbers, booleans, arrays, objects, and even functions. So you can access sub-properties of objects by chaining together your dot or bracket notation. So let's look at this. We have our storage object. It has two properties. It has a desk, it has a cabinet. Let's look at desk first. So desk has a value of another object. In this object, you have a property of drawer, which contains stapler and pen. You can see how it models your real-world representation, real-world objects. Our storage, our desk is considered a storage, and our desk, especially if you have those kind of like put in throughout drawer, you can put in things like stapler and pen. So it's similar. You can represent this using JavaScript object. Then next we have cabinet, and in cabinet you have a top drawer. Inside this top drawer, you open up a drawer, you get a C folders. And in the first folder is our contract folder. So how do I access? So if I want to access contract, how do I do it? So you can do it from the top to bottom. So at the top, we have our storage. Then we have cabinet. Then we have top drawer. And we have folder 1, which you can see over here. Cabinet, top drawer, folder 1. And you get back contract out. Similarly, if you want stapler and pen, you go from top to bottom, our storage, then desk, then drawer, then you get back stapler and pen out, which you see over here, storage, desk, drawer, and you get this out. Okay, then that's all for this workshop. So thank you for joining us, and if you have any feedback, you can go through this link, this QR code. You can send this QR code and send in your feedback. So if you have any questions, you can also post them now in either the Padlet or in the Zoom chat.